This lesson, you guys, is about displacement and position. We're going to throw distance into the mix as well. And I definitely recommend watch this little video. It's just a good little primer as to the difference between displacement and position. First thing we need to talk about, though, is vectors to kind of get into this. So let's choose a nice happy orange. We're going to talk vector versus scalar. Vectors have both magnitude and direction. Scalars, on the other hand, only have magnitude, so you can see no direction. The scalars lack direction. And if you're wondering what on earth this magnitude is, it's the number plus the units. So, for example, I could say I walk 10 kilometers. If it's just I walk 10 kilometers, then that's a scalar. That's like this guy down here. If, however, I told you I walked 10 kilometers and I went north, that has both magnitude and direction. That is a vector then. Something in physics that we do is we use these kind of square brackets around our directions. It doesn't need to be so bold, but we use square brackets around our directions. You'll see me do that, and I'll require you to do that as well. A couple examples with this then. So what we were just talking about up here is if I told you I walked 10 kilometers north, that is a displacement. So as an example, if I told you I just went for a 10-kilometer jog, no direction on there, that's just distance. Okay, so this guy right here is distance. This guy up here is displacement. A couple other examples. We'll talk a lot about velocity and speed. They're pretty similar. Speed just has magnitude and no direction. Velocity has magnitude and direction. A couple others, time, mass. These two are ones that are common, things like 10 hours or 70 kilograms or something like that. Those guys are super common scalars. They never have direction. These guys, you could give them direction, in which case they kind of become a vector. So some of the scalars are very similar to vectors. Some of them, like this time and mass, they just sort of never have any direction. Let's talk about position, displacement, and distance then. We'll run through a little diagram to kind of show the difference between these definitions, but a couple of things to point out first. Notice the symbols. They are all D. We like to cause maximum confusion in physics. So they're all Ds, but you'll notice a couple differences with them. Position up here has this little arrow on top. That little arrow, sometimes you'll see it written like this, kind of a half arrow. That little arrow on top shows that it's a vector. It shows that it has direction. Same idea with displacement. If we go down to this one, you can see it's got an arrow. It's also got direction. And you notice distance at the bottom here has no arrow, no harpoon on top. That little thing sometimes is called a harpoon. That's getting worse and worse, but that little arrow right there. The distance one here has no arrow on top. It has no direction in its definition. Something else that you can notice. Whoop. Oh. Not that. There it is. Let's get that off. Put this on. And go back if I can. Whoops, that off. There we go. Oh yeah, this triangle right here from your math class, that triangle is the delta symbol. Delta just means a change in something. So for example, in this case, delta D means D final minus D initial. These guys are vectors. It's a change in position that we're talking about. Okay, so if I was to draw a little diagram of this, let's say I have a house here. Here's where I live. And near my house, there's a Tim Hortons. Always got to stop at Tim Hortons on your way to work. And let's say the school is up here. And we'll make it look a little bit like a school. So there's the front doors. Here's some windows up here. Let's see, our class is somewhere right above the front doors, I think. Maybe off to the side a little bit. Let's say I start my car at Tim Hortons and I drive on this windy path to get to school. So I'm driving in this direction and I end up at school. The length of that windy path would be my distance. I don't know, we'll make up a number, 15 kilometers. That's D for distance. Let's see, how do I get this pen to come down reliably? There it is. Let's go to orange and we'll see if we can get back by making a botch of this. The displacement, on the other hand, is a straight line from start to end. So wherever I started to wherever I ended, that straight line there, that orange line, that is displacement. Okay, so displacement is kind of, it's the change in position, or you could say it's the straight line from start to end. I have a lot of trouble switching pens, as you can obviously see. Let's get out of here. Back to this one. Okay. So if the orange line is the straight line from start to end, what on earth is this position? Position is where am I? Where did I end up compared to a reference point? So a common reference point for you, if your mom or dad or somebody at home calls and says, where are you? They call you on your cell phone. You say, I'm at, I don't know, so-and-so's house or whatever. They don't know where that is. They want to know, where are you compared to home? So in this example here, in my little example, you could say that the position is this green line here. It's how far am I from home, or from whatever reference point we choose, right? That's a common one though for your family. So the distance is length of the blue line. That's the squiggles and all, or curves and all. The orange one, displacement, is straight line from start to finish. The green one is straight line from reference to finish. And just notice that both of those vectors will have to include direction. All right, let's see if I can get this without, get rid of all these extra marks here. Pull that down. Let's go blue. All right, so let's say I'm going to walk 10 meters east and then 13 meters west. Just notice this over here. I've kind of labeled some directions over here, so I know north is going to be towards the top of the page, east is kind of to your right. I'm going to go east, so I'm going to go this way. Let's say there's 10 meters. Then I'm going to turn around and I'm going to go west, and here's 13 meters. For distance, I don't really need these directions over here that we're talking about. Distance total, sometimes people say DT, D total, is D1 plus D2 plus D3 plus D4, however many of them you've got. D total then in this case is 10 meters plus 13 meters. We could do this in our head, but it's nice to sometimes see it written out like this so that we can kind of see. For easy ones, it makes sense, but as we get into harder ones, sometimes it's less obvious. So here's kind of a method we could use to figure out the distance that I went. The displacement, on the other hand, is a little bit different. Remember, we talked about the displacement being the straight line from start to finish, or end, or whatever. Okay, so let's go, let me draw this one in green here. The straight line from start to end is right here. Again, you could probably do this in your head. If I walk 10 meters to the right and 13 meters to the left, this has got to be 3 meters in here. But I want to walk through how we figure that out when it's a harder question. Okay, so the displacement is, here's how we're going to do it. We're going to say the displacement, and people often use total or resultant as another letter that you see. Sometimes you'll see DT or DR. It is still displacement 1 plus displacement 2. Again, if there was 3 of them, I would say plus displacement 3 and so on. What we're going to do, though, is what I've said over here in this axis system here, this little coordinate system, I've said the east vector is positive. What that means is my 10 is going to go in as positive. The opposite direction, then, the west one, that guy's going to go in as a negative. So when I sub these numbers in, I'm going to say 10 plus negative 13. And that's going to give me, this is a triangle here, the delta sign. That's going to give me negative 3 meters. The direction of my first answer is always in the positive direction up here. So negative 3 meters east. And negative 3 meters east, it's a little bit like saying I'm going to aim east but back up. So this thing says aim east and the negative sign over here says back up. That's a little bit the same as turning around and facing west. So if I face west, then I'm going to go forward. Okay, so now I'm saying go forwards, but face west. Okay, so negative 3 meters east, if I switch the positive sign, switch the negative sign to a positive, I also switch the E over here to a W over here. This is my answer here. So 3 meters west is kind of the answer on this. If you remember our SIGDIG stuff from our math review, I really should write it as, you could say it's something like this, therefore displacement, resultant displacement if you want, 3.00, if there's 3 SIGDIGs there, 3 SIGDIGs there, I'm going to keep 3 in my answer. Notice the square brackets there as well. There's actually the final answer. Maybe we'll stick 2 boxes around this guy. There we go. Oh, and I wrote all over this question, so let's do this. Let's go out of here. We'll discard the changes. We'll start it again, and we'll get into this guy here. For okay, so collinear means straight line stuff, so I'm going this way, and then I'm going in a parallel direction this way. Non-collinear, again, imagine the same coordinate system here. Non-collinear means this. If I was to go 3 meters east, so there's 3 meters, then turn and go 4 meters north, okay, this is non-collinear. The vectors aren't parallel to each other like they were in the first example. Here they go in opposite directions. Or not opposite directions, but perpendicular directions. For distance, I'm going to squeeze it over here on the side. So let's say for A, distance total is D1 plus D2 again. This is just 3 plus 4. Distance total. That's just 7. I'll say 7.0 meters again for SIGDIGs. There's the answer to part A. Let's look at part B. Let's go to blue here. Part B is the straight line from start. So again, remember that's where I start, or the chicken or whatever it is starts, and this is where it ends. The straight line from start to end is this thing right here. This is my displacement. Okay, so I need to find out the length of that blue line. Now I can use any math that is sort of valid and I know about. In our case, this looks a lot like a right angle triangle. I'm going to use Pythagoras. Okay, so using the Pythagorean theorem, P theorem, I'm going to say d squared, and you can keep it with all of its kind of hardware. D squared is equal to 3 squared plus 4 squared. That's 9 plus 16. D squared. That is 25. Take the square root of both sides. Delta D is 5 meters, 5.0 meters. But remember, as soon as I put this little vector sign on the front or on the top there, I need to know a direction. The direction is, what is the angle at the starting side? Okay, so I don't want the ending angle up here. I want the starting angle. So down here where I started, I need to find that angle. So here's where not only do I have to use Pythagoras, I got to use some trig as well. So I'm going to say opposite over adjacent. I'm going to say tan theta is the opposite side. So 4 over this adjacent side over here. So 3. Do I have that somewhere? Let's work it out. 4 divided by 3. 53 approximately. 53 degrees. 53.1 or something. 13. So what I'm going to say then in my answer here, let's give myself a little more room. What I'm going to say in my answer here is this 53 degrees, so right in here, it touches east. So I'm going to say east first, then 53 degrees, then the other direction that this chicken went was north. So you could look at it in order. You could say the chicken went east first, north second, so I get east first, north second. Or you could say the 53 degrees here touches east. It also touches the hypotenuse, but between east and north, 53 degrees touches east, so east is going to come first. The one that it doesn't touch is north, it comes second. Okay, and there's my answer to that thing. So here's one for you to try. I want you to pause this video, try this one out, and then I'll do a solution. I'm trusting you guys now. Pause the video, try this one, see how it works. Okay, hopefully you're unpaused and you've already solved this thing. Let's choose blue. Yeah, blue's nice. For distance, this is nice and easy, right? distance is d1 plus d2. Somebody always asks, do I need to show this? Yeah, it's a good idea. If you want good communication marks, show me this work. This is 10 meters. Again, 2 sig digs, 2 sig digs. I'm keeping 2 digits in my answer. Sometimes people put a dot at the end of it to show that it's 2 sig digs if you're concerned about the 0. This is 10 meters, and that's it. No direction. For displacement, that's always the one that's a little bit harder. I'm going to draw it. So I'm going to go, let's say B is over here. I'm going to go east this way, 3 meters. I'm going to go 7 meters south. The displacement is the straight line from start to finish. That's not very straight, but let's imagine that's straight. And again, start is over here, ending or finishing or whatever is here. The arrow should point towards the ending. Okay, so my arrow is here, not pointing back towards the start. So I'm going to need to find this side. That's displacement. I'm also going to need to find that angle. That's the starting angle. Okay, so to find displacement, we can say displacement squared is 3 squared plus 7 squared, just using Pythagoras. Displacement squared is 9 plus 21. That looks like 30. We take the square root of both sides, and we're going to get approximately 7.6, 6 meters. Again, we need a direction. Okay, so we're going to find that angle in there, and we're going to say tan. I'm a tan guy. I tend to use tan a lot. Tan theta is opposite over adjacent, so 7 over 3. On your calculator, just as a reminder, make sure you're in degree mode. Your calculator should say D or DEG or something, and probably in some fine print somewhere around your screen. 7 divided by 3, 2.333. We're going to go shift tan, or second function tan, of that answer. And we're going to get 66.8 degrees, so about 67 degrees. And then I can, excuse me, I can write my final answer with an arrow on top. Displacement, 7.6 meters. This is east, 67 degrees. Where's my eraser? 67 degrees south. Okay, and let's just do a quick direction check here. I went east first, so east comes first. I went south second, so south comes second. You could also say that the 67 degrees, so 67 degrees right here, touches east, so east comes first, south comes second. Okay, so that's how we kind of write those directions in there. And that is it. You guys can try some of these questions. Ask me if you have questions.